This question wants us to find the volume of revolution generated by revolving the region bounded by the curve y equals to x squared plus 1, the y-axis, and the line y equals to 5, about firstly the x-axis, then the y-axis, both of which through 4 right angles. So, what are the regions that we're actually talking about here? What's this region that we're actually talking about? We're talking about this region in here, between the y-axis and the curve y squared plus y is equal to x squared plus 1, and the line y equals to 5. And first thing we're asked to do is to revolve it about the x-axis. Well, we have a formula for the volume of revolution about the x-axis. What is it? Well, firstly we need to know the bounds. First bound's quite easy. This is 0. The second bound is here, right? This is 2. So again, all you do there is you set 5 is equal to x squared plus 1, x squared is equal to 4, x is equal to plus or minus 2, but obviously we're looking at the positive half. So this is 2. Okay, so what happens next? Well, we have a formula. This is going around the x-axis, so we've got a way of doing this. We know the volume of revolution for an object around the x-axis between x is equal to a and x is equal to b, so I can write that as x equals to a and b, from x equals to a to b, is pi y squared dx, the integral thereof. So in our case, we want to find the volume of revolution of this funny shape. So this one we don't have a single y expression for. Instead, what we're looking for is the difference. What we're going to do is we're going to find the volume of revolution for this y, and then subtract away the volume of revolution for this y, and that should give us our answer. So how do we do this? Well, let's have a go. So the volume we are after is equal to the integral of 2 to 0 of our big one, 5 squared pi dx, and then we subtract away the integral from 0 to 2 of, and then we use this one, the x squared plus 1 squared pi, again from again with respect to x. So what is that going to be? This is the integral of 2 to 0 of 25 pi dx minus the integral of 0 to 2 of x to the 4 plus 2x squared plus 1 pi dx. What does that give us? Well, I've got pi here, I've got pi here. I may as well bring it out the front. And then we get the integral of, integral of 25 pi, well that will give you 25 pi x. We've already taken the pi out, so just 25x between 0 and 2 minus, we do this one, we get x to the 5 over 5 plus 2/3 x cubed plus x, again between 2 and 0. Fantastic. So now we can evaluate this. So this gives us pi. This one, substitute in 2, you get 50 minus 0, so this is 50 minus, and this one, what are you going to get? You're going to get 32, 2 to the power of 5 is 32, divided by 5, plus 2/3 times 8, plus 2. And when we simplify this, we get pi 50 minus, this is 16 over 3, well, this is a good chance to pull out a GC, so hold on. So this is my GC, Microsoft Mathematics 4.0. It's a free download if you want it. So let's take a look at what our question was again. We need to figure out what 50 minus, we'll just do the whole thing, 50 minus 32 over 5 plus 2/3 times 8 plus 2 comes out to be. So we're just going to type that in over here, and this is 50 minus, and what was it? It was 32 over 5 plus 2/3 times 2/3 times 8 plus 2, and then minus a bunch of zeros, so we don't worry too much about that. So our answer comes out to be 36.2, or 544 over 15. Okay, so our answer then here is 544 over 15. So our volume is 544 pi over 15 units cubed. Yep, so our final answer is indeed 544 pi over 15 units cubed. So that settles part 1. But we're actually given a second question. We're asked to find the volume generated by the region, same region, when it is revolved around the y-axis through 4 right angles. So this time we need to look at things a little bit differently, right? Instead of doing this, when we had to revolve something around the x-axis, what did we do? We came up with this formula. The volume is the two bounds in terms of x, between the two bounds in terms of x, of pi y squared dx. That's how we do it about the x-axis. Well, how do you do it about the y-axis? It turns out it's very, very similar. You find your bounds in terms of y, so say from d to c, and then it's pi x squared, why did I put brackets there, not sure, dy. So it looks pretty much the same, right? Now the only trick is, this x here, this must be a function of y. The same way that this y here is actually a function of x. So like y equals to x squared plus 1. It's y in terms of x. Similarly, this must be an x in terms of y. So this is the trick we're going to use, and in fact it makes life a little bit easier for us. But let's not get ahead of ourselves. Let's first of all find the bounds. This one's easy enough. This is y is equal to 5. What about this one? Well, this is x equals to 0. This means substitute 0 in here and you get 1. So we're looking at integrating this between y equals to 1 and y equals to 5. What are we looking at integrating? Well, if you look at what's trapped here, it's this curve here, right? This one here. So we need to find out what this is, what this function is. What is x? In fact, let's go all the way over here a little bit more. Maybe I've got some more space. No, I don't. So, let's get rid of some stuff. Let's get rid of this. So, we have y is equal to x squared plus 1. That means x squared is equal to y minus 1. So x is equal to the positive or negative square root of y minus 1. But quite clearly, right, y is above the x-axis at all times, so we don't worry about the negative part. So x is equal to the square root of y plus 1. So that's going to be our function of y. So now to integrate this, let's find our volume. So we want to find the volume when we integrate between what? Between y equals to 1 and y equals to 5. Between y equals to 1 and y equals to 5 of what? This line here, because this is the one that's above or to the right of the y-axis. So then this one is precisely this. X is equal to the square root of y minus 1. So for the moment we'll just leave it as x, I suppose. And then with respect to y, sorry, what am I talking about? It's should be pi x squared with respect to y. So this is the integral from 1 to 5 of pi square root of y minus 1 squared dy. What's that? 1 to 5 of, and let's bring the pi out the front, y minus 1 dy. This is easy enough to integrate, so this is pi half, it's a bit messy, a half y squared minus y between 5 and 1, and we just evaluate this. So this is 25 over 2 minus 5 minus a half minus 1. So in other words, this is pi times 12.5 minus 5 is going to be 7.5 minus 0.5. No, sorry, not minus 0.5. This is a half minus 1, so this is going to be negative half. So it will be plus. So our final answer should be 8 pi units cubed. And we are done.